definition of exponential functions. Okay, the exponential functions are given by the equation f of x equals a times b to the x. Okay, now keep in mind that a and b are real number constants. Okay, those are not variables; those are real numbers. A cannot be 0. How come my a value cannot be 0? Take a look at that. What happens if a is 0?
The whole fraction becomes 0.
And then everything's 0, because if a is 0, a times b to the x, that would just be 0, and we have no more exponential. We just have a straight line, y equals 0. Okay? B is a positive number. Doesn't always have to be, but in this case, here, b is a positive number, and b cannot equal 1. Okay? Why, or how come b cannot equal 1? What happens if b is 1? A times 1 to the x.
Then the x equals 0.
Yeah, it doesn't matter when x. 1 to the third is 1. 1 to the 15th, it's 1. 1 to the negative 7, it's 1. So basically, I'll just have 1 times a, and I'll just get a, and I'll have a straight line. Y equals a. Whatever number a is, let's say it's 5. We'd have y equals 5. So b cannot be 1, and a cannot be 0. Otherwise, we will cease to have an exponential function. Okay? Now, couple things here. A is what we call the initial value, and B is the base. Okay? B also tells us other things, but we'll get into that in a moment. But A is what we call the initial value, and B is the base. Determining the exponential function from its table of values. There's a problem. I don't know where it started. I've heard it from several people. The Bill Gates problem. The Bill Gates problem. Let's say Bill Gates hires you for a month and says, I will give you $10,000 for that month. You can either accept $10,000 as your salary for the month, that's it, no matter how much you work, at least 8 hours a day, and you get 10 grand. Or, what I'll do is I'll give you a penny the first day as your salary, and I will double every day. So meaning day 2 you get 2 cents. Day 3, it'll double from 2 to 4. Day 4, it'll double from 3 to 8, and so forth. Would you take your penny and double it for the month, or would you take your 10 grand?
I mean, wouldn't you get more for a while?
I don't know. That's the question. Well, how long is a month? Is it 30 days? Because that's how long a month is? Or is it 20 days? Because that's really work 4 weeks. Does it matter? No. You get a penny for day 1, and a day 2 it doubles. You get 2 pennies, 2 cents. And a day 3, your 2 cents doubles to 4 cents. See, this is your days, and this is the money you'd make. 1 cent, then your second day would double to 2 cents, your third day would double to 4 cents, your fourth day will double to 8 cents, and so forth. And so forth. 5 days, right, would be 16 cents, the 6th day would be 32 cents, and so forth. So what would you take? Would you take the 10 grand, or would you take the penny double? I'm taking it. Okay, so, let's say, should we make it 30 days in a month? 30 days in a month. Because he's got all that type of money, right? 30 days. All right? Now, quick question. What would be, I hope, the value of f of 0? So when x is 0, that's when you initially start. What's your salary? Careful. Look at how these relate to each other. We say they double, right? They go up. It's like times 2, times 2. It's not 0.2, it's times 2. So if I'm going backward, what am I doing? I'm taking half instead of doubling. So it's half of 1. It's half of a penny, right? We'll call that 0.005. Now, how come it can't be 0? Because when we are finding an exponential, a cannot be 0. Otherwise, your salary, using that equation, it would be 0. You make nothing if a was 0. You see what I'm saying? So our initial value cannot be 0. Okay? So let's come back here. So we know that our initial value is right here. This is our initial value. That's our a value. So we're trying to find this function. We know that f of 0 is 0.005, and that is our a value. That's our initial value. So I'm just going to substitute that in right here. We now have 0.005 times some b value raised to the x. Now, x is our number of days. But what is the b value? The b value is our base. What's the base of the exponent? None of the number seems up here on that list now. Yeah, but it only appears once. Then it goes to 2, 7, 4, 7, 2. Where does 2 appear? Yes, but what does it do? What's 2's purpose? It doubles. From day to day, it always doubles. So we are always doubling our value, our f of x, right? Our b value, which is our base, is also called our factor. That's what's happening. It's our factor. That's what our function is being multiplied by. Think about it. Oh, yeah. So let's think about it for a second. Okay? If I'm on day 3, I'm going to start, right? I got to double from 1/2 to 1, right? Double from 1 to 2. I got to multiply 2 3 times, right? So it's 2 times 2 times 2, which is also 2 to the third for day 3. On day 5, I got to do 5 doubles, don't I? Yeah, so it'll be 2 to the 5th. So our factor, I mean, we're really multiplying by 2, but how many times are we multiplying by 2? 30. That's what our exponent is. In this case, if we go 30 for a month, let's do that. So if I do f of 30, someone tell me what it is.
5 minutes.
Apologize for the interruption. What is f of 30? What is 0.005 times 2 to the 30? What is that? Someone read that number out to me. 5,368,000
and then 700.
709. What about the change after
And
that?
then 12 cents.
Okay? Yeah, if he's going to pay you for 30 days, you definitely take the penny, double it. But what happens? What happens if it's only 20 work days? What's f of 20?
It's 5,000.
It is 5,242. Is there any change? What? 88? So guess what? If he's selling you 20 days, you take the 10 grand. What a difference. What a difference between 20 days and 30 days in salary when you double it. What a huge difference. Right. Now, the word exponential means it grows, each time it grows faster and faster, the gap between the previous value. What do I mean? Well, you're like, Visca, you said it doubles every time. It does. We know that it doubles every time. I'm going to erase some of the stuff to show you something here. So between each value, you're always multiplying it by 2. But look at the difference. Okay? The difference between this one, this is the difference now. It's a half a penny it goes up between here and here, right? Between this value and this value. Now, how much does it increase between 1 and 2? A cent, right? How much does it increase between 2 and 4? 2 cents. How much does it increase between 4 and 8? 4 cents. This is the amount it goes up. See how the amount that goes up is constantly going up and up and up? It's not the same. It's not the same. Okay? That's just multiplication. The difference in my salary between day 1 and 2 is a penny. But the difference between my salary and day 4 and 5 is 8 cents. From 8 to 16. It will constantly go up at a bigger and bigger and bigger rate. And that's what exponential means. Grows. Based on the table of values below, determine the exponential equations for g of x and h of x. These are x values. Okay? These are x values. We're going to find an equation for this And then we're going to find an equation for this. All right? So if I know my exponentials at this point are a times b to the x, okay? I want to find out what g of x is, and I want to find out what h of x is. How do I find the a value here? How do you think I find the a value? Think back to this Bill Gates problem here. How do we find the a value? How do we find the a value? Where it started. Where x is what? Where x is 0. So now we're going to go fast forward to this next slide. What is our initial value for g of x?
4.
It's 4. Because that's where it's 0. What's our initial value for h of x? 8, because that's where x is 0. So I know this is going to start with a 4, and this is going to start with an 8. Now, what is my b value? What's my factor? What's my factor? All right. What's the b value? Donovan.
Yeah.
How do we find the b value here?
I think
What did you tell me the b value was? You came up with that answer.
2.
It was 2.
These two being double.
Yeah, because this was being doubled. So let's look at g of x. What's happening to these numbers here?
Being triple.
It's being tripled. Because 4 to 12 is times 3. 12 to 36 is times 3. Now, what about this? How do we know this is times 3? Well, if I take 4 over 9 and multiply it by 3, don't these cancel? 3 goes into 9 3 times. Isn't that 4/3? It sure is. And look what's next, 4/3. So I know it's being multiplied by 3, so what do you think my base or my factor is for g of x?
2.
It's 3. Well, there you go. That's how you come up with the equation. Why don't you guys try to figure out what h of x, the factor or the base for h of x would be? It's 4. Is that what you guys, is it right? 4?
Yep.
So let me do this. Then to go from 8 to 2, I multiply it times 4.
So you divide by 2.
I divide by 4. When we think of multiplication, dividing by 4 is the same thing as multiplying by 1 over 4. It's the same thing as dividing by 4, isn't it? What's a quarter of 8? 2. The same thing. I divide, you can say, oh yeah, well you divide by 4, it's the same thing as multiplying by 1/4. So my factor is 1/4. All right, next slide. Let's determine which are exponential functions. For those that are exponential functions, let's state the initial value and the base. For those that are not, well, tell me why they're not. So example 1, exponential function or no? No, it is not. How come? What would that graph look like?
A line.
A line. That's y equals mx plus b. Classic. That is linear. That is not exponential. Number 2.
Yeah.
You know than a yeah. What are we doing?
I think it is.
You think it is? I'm hearing no's. Anybody else?
Okay, yeah.
No.
Yep, just the base. Oh wait,
Yeah, but
I'm looking at
3.
I'm looking at 3.
Look at 2.
Oh,
That is. So, what's the initial value? Don't forget, it's a b to the x, right? A is our initial value. I don't know. 1. It's our initial value. Go to it's a 1. So my a value is 1. What's my base?
E.
E, the number E. That is actually a number E, so 2.718 something. What about 3?
Yes.
I'm hearing no's and yeses. Maybe. Well, what's one thing besides looking for an initial value to base? Why do you know whether something's an exponential or not? The exponent's a variable. Your variable's in the exponent. So here's the debate. Is 3 exponential or not? I see the exponent is a variable, but guess what? So is the base. This is no. How come? Because there's a variable in the base. For an exponential, for a function to be an exponential, the variable has to be in the exponent only. That's where you get the term exponential. It's an exponent. All right, number 4. What do we got? Exponential, yes or no?
Yes.
Yes, good. Yes. So what's my initial value? 2. What's my base? 3, which is also known as my factor. Number 5. What do we got? No. Does anyone know? I mean, you haven't seen this too often or heard it referred to too often. Does anyone know what that is? It's not linear. It's not exponential. This is known as a power function.
Power.
Because we are taking our variable and raising it to a power. That's why it's called a power function. And last but not least, number 6. What do you think? Yes. Several of you told me yes, and you'd be right. Yes. What is my initial value? 1. What is my base? 5. Pretty good, guys. Exponential functions. Exponential functions, all right? Now, the base, which is our b value, of an exponential function, it's a lot like the slope of a linear function. It tells us whether the function is increasing or decreasing and by how much. Okay? Right, like that Bill Gates problem, everything was being doubled, wasn't it? Doubled. G of x was tripled, and h of x was a quarter. Was quartered. Yeah. So that tells you whether a function is increasing or decreasing. So, for example, if I go to my calculator here and I go to type in, let's be really something with an exponential, and I say 2 to the x. Okay, that base is positive. Okay, so that should be an increasing graph, right? So when I graph it, there it is. That is increasing. As my x value gets bigger and bigger this way, the y value goes higher and higher. That's the increase right there. Okay? But you need to be careful because it's not whether b is bigger than 0 or not. If b is bigger than what number, the function increases. Any guesses? It's not 0, because if b is 0, 0 to any power is 0, and that turns our whole function into 0. It's 1, because everything is by 100%. If I give you $100, and next week you have 100, you still have 100% of it. If you come back with 90, guess what? You have 90% of it. That's less than 90%, 0.90. So if b is bigger than 1, the function is increasing, which, by the way, in terms of exponentials, we call that growth. And if b is less than 1, even if it's negative, okay, it is decreasing, which we sometimes refer to as decay. So there's growth and decay, increasing and decreasing. Okay. So if I make my 2 less than 1, let's call it 1/2. Okay. Y equals, I will say clear 0.5 and raise it to x, and I graph that. That's decreasing, isn't it? As my x gets bigger and bigger, my function goes down and decreases. It's exactly what we just said it would. What if it was negative number? Would it decrease? I don't know. That's what y equals. Square it out, plus -2 and raise it to the x. Let's see if that decreases. It does. It just flips because it's negative, right? Isn't it a negative flip? Bam! Decreasing. Okay? As x gets bigger and bigger this way, y gets smaller and smaller this way, so it's decreasing. Now, there's one exception here that I want to point out. A negative exponent can counter effect the base. It says of base. But it can be a counter effect of the base. Meaning, if I take a look at this function right here, we say that it's decreasing. Why? Because my base is smaller than 0, isn't it? But what happens when I negate my x? Yeah, what happens when you have a double negative? Does it go positive? I have a decrease in my base, but also a decrease in my exponent. It's like multiplication. A negative times a negative is positive, right? So when I graph that, that should be a positive base. And it does. Which means as x goes further and further this way becomes positive, y goes further and further up, which is also going in the positive direction. So, let's determine which exponential function is growing or decaying. And give the growth or decay factor. Okay? What percentage is the function growing or decaying? Okay? So look at number 1. Is that increasing or decreasing, growing or decaying?
Decreasing.
That's decreasing because my b value is less than 1. So it is decreasing. And at what rate?
Quarters.
A quarter, 25%, right? So actually, you could say it's decreasing by 25%. It's a drop by 25%, or 0.25, whatever you want to say. What about number 2? It's increasing. It's increasing. And what's the factor, the growth factor? 4. So the growth factor is, it's multiplied by 4, or you can say 400%. What about number 3? So number 3 is what? Increasing or decreasing? Okay, well the base tells me it should be increasing because it's bigger than 1, right?
Yeah.
But isn't a negative exponent flip that?
Yeah.
So it should be decreasing. And it's decreasing. Now, by a factor of what? 2. Or 200%. Right?
Example 4.
Increase or decrease? Increase. By a rate of what? This is just my initial value.
Oh, so it's 2.
Yeah, it starts at 3, and 3 gets doubled instead of 1. You see what I'm saying? So it is still by 2, or by a factor of 2, or which is 200%. Now, decreasing. Very good. I think we should take a look at this graph and see what percent it goes up or down. Because it might be 2. Okay, but then there's that 5 minus x. You see what I'm saying? Let's take a look at this. Let's try to figure this one out algebraic. Wow. Okay, so y equals, we're going to clear this out. It is 2 to the exponent 5 minus x. We're saying that's a decrease. Let's take a look at that, see if it decreases. That is definitely decreasing. As we go further and further to the right, as x increases, my y value is decreasing. But by how much? If I look here, we want to say 2 because the 2's in front, right? So let's go at our table. And what is it?
No.
2.
It's decreasing by 2. So it is half, right? It is half. Because it goes from 32 to 16. 16 to 8. 8 to 4. It is cutting in half. So that 2, it's not doubling.
It's 1/2.
It's 1/2.
It's decreasing.
So 50% decrease by a factor of 2, which is like dividing by 2. So by 1/2 or 50%, right? Last one. Increasing or decreasing? But the exponent is less than 1. That's right. It doesn't matter if the exponent is less than 1 or not. It matters if the b is less than 1. The exponent, as long as it's positive or negative, that's still a positive exponent. So that is increasing. Now, this is interesting. That's increasing. Now, if that was 4 to the x, we know it'll go up by 400%, right? Just 4 multiplied by 1. But it's the x divided by 3. So let's do something here. Let's take a look at this on the graph again and say, y equals, we'll clear this out. If I just had 4 to the x, and I graph that, that's what it will look like. It goes up steep. But we don't have 4 to the x, we have 4 to the x over 3. That's right. It increases, the rate goes up by like a third because you're dividing the exponent by 3. So, we know, oh my God, we know that our first one goes up by 4 every time. But this one goes up from 1 to 1.5. So more than 1.5. And from 1.5 to 2.5 approximately, 2.5 to 4, this is what I'm going to do. So I can see both of these things right here. Put this out right here. And if I want to figure out, I don't do that. There we go. If I want to figure out what this rate is of change between these two, how can I do that? It goes from 1 to 1.5874. But what is 0.5874? You guys remember how to, oh man, this is algebra back in the day. How do I find the percent of increase or decrease? The difference of the two over the original. So if I do 0.5874 and divide that by 1, because that was the original where it started at.
Wait, is it 1.58?
No, I think the difference. Let's do it this way. Let's do it another way. Let's take the next two. So do the same thing. Oh, the difference of the two. So we're going to take 2.5198. We're going to subtract 1.5874. That's the difference over where it originally started between those two. 1.5874. Is that really close to 0.5874? It is. So, the percentage of increase is this. Or this, we were to round it, 0.5874. Let's say it's approximately 58% increase. Okay? You see how I did that? Sometimes you really got to go to just basic algebra to figure it out, percentage. Okay? So, we're going to go here. It increases, approximately 0.5, well, actually, that'd be 58%, wouldn't it? 58%.